The slope of the pink line, we find with rise over run. I know that from P to Q, it went up 3, and it went over 4. So the slope of the pink line is 3 over 4. I need to find the slope of the orange line here. So m of, what do we call that one? We called it u, vector u. That's just a subscript. Don't let that throw you off. I'm just saying the slope of given vector u. So if I look at from A to B, we went up 3 and we went over 4. So they have the same slope. Okay, so remember this whole point of us studying mathematics is not only to write out mathematics, right, to solve things, but to be able to talk about complicated things clearly. So since the distance, and we should, we'll do this, we'll write it out. The distance between P and Q, which is the magnitude of vector V, is 5, which is also, I'm just going to do an equal sign running here, is the magnitude or length of vector U, which is the distance between A and B. So since that's true, and PQ and AB have the same slope, then V and U are equivalent. I said this in class today, shorthand's fine, but it needs to be clear. It needs to be able, like, I don't need to be, I had a friend that I used to text, and he would do, like, abbreviations, and, like, like, on my way, OMW. I understand that one. I understand a bunch of them because I grew up in the era of texting with a 10 key, right? I got used to that. I know what it means. I can figure it out with that stuff. We needed the shortcuts. The problem is my friend would do like, see you at the mall, and he would like spell out those letters, and I'm like, I don't know what that is. Don't do that kind of thing when you're abbreviating math. Everything needs to be logical. There are tons of symbols to save you time. I saved out, since the distances are the same between these based on what I found, which is exactly right here. I wrote it in one equal sign, but I was clear. So you can do that and abbreviate, but just make sure it makes sense mathematically. You're not just making up your own notation. And then also grammar needs to be okay, decent. Math grammar, they get a little iffy, not too picky, but they're there. Right, the standard position of a vector. This is how we typically think of a vector in standard position. Remember, I could put that vector PQ that's on the screen right there. I could put all over that graph, and it's the same thing. As long as it has the same size, length, in the same direction, it points the same way. What we call vectors, this is called component form. And if you look here on our graph, we start at 0, 0, and we go to V1, V2, that point, 0, 0 to V1, V2. So our vector explanation, this tells me how much to go in my x, right? So this is x movement. And then this one is y movement. It tells me where to go. Right? So in this case, whatever V1 and V2 are, it goes over V1. In this case, on the picture is 3. So if I were to write out this vector, it would be like this. Go up, go right 3, go up 2. It's almost like a slope in a way. All right, so that's how we write out vectors. Be very careful. There is a giant difference between the vector and the point. Right, vector has the like slant brackets, and it tells us a direction and a magnitude. We'll talk about how to get that magnitude given those two numbers. And then if I put parentheses around it, it's literally just the point, V1, V2. The left one represents the actual vector, the ray, the directed line segment. And then on the right side, the point is literally just a point. I won't read this definition to you. It is the component form of vector. We just talked through that. This definition implies that two vectors, if this and that are equal, the only way, that's what this if and only if, The only way those two things are equal is if v1 equals u1, that's this one equals this one, and this one has to equal that one. It has to be like componently equal. So if I look over here to the right, I made an example here. Is the vector 3, 5 the same thing as negative 1, 5? No, they are not the same thing. They literally have to be the exact same numbers there to be the same vector. Okay, a couple things here. We've got some definitions for you. If I have 2 points from P to Q and I want to find the vector form, right, the component form of this vector, I do as follows. Here, a couple things. Initial is where it starts, that's P. And then terminal is where it ends, that is Q. So if I want to find the component form, I take terminal minus initial, the second one minus the first one. So notice here, they did Q1 minus P1. Here they did Q2 minus B2. And that'll give us our vector form. We'll do an example of this here in a moment. Now, with that component form, we really do want length of the vector. I don't want to have to draw it on the graph and use the distance formula each time, because I'd have to draw the graph to use the distance formula. I need 2 points. Here is something we're going to use a lot. This is the magnitude of V, or the length of V, also called the norm of V. It is used with that formula there. So notice if I have component form, that's like saying if this vector is V1 and V2, I just run this formula and that'll tell me the distance. This is just the distance formula, right? If I take these 2 points up here and run the Pythagorean theorem, do the distance formula, you'll notice that that is the exact same thing as the formula I have there starred. This is one that you need to memorize. This isn't one I would give you on a test. Number 2 starts, if I have component form, there's my vector V, then V can be represented by the directed line segment in standard position from 0, 0 to the second quote V1, V2. The length of V is called the norm of V. All right, we just said that's just distance. If V, this is an important part that's going to pop up a bunch. If the distance or the magnitude of vector V, that should be a bold V there, if it's 1, then V is a unit vector. A unit vector is a directional vector with a length of 1, meaning unit, right? Just like trig, unit circle. The reason it's called a unit circle is because the radius was 1 all the way around. Moreover, if the magnitude of a vector is 0, then it's called the 0 vector, and it's just this. Oops, I'm on my highlighter. I write it like that. All right, the 0 vector, 0 in any direction, just a point. All right, example 2, let's run through this one together. It says, find the component form and length of the vector V that has initial point, 1, negative 4, and terminal point, negative 3, 6. So if I wanted my vector V, I would take the terminating point, negative 3, minus the initial, which is 1, comma, I take the terminal point, which is 6 in the y, and then I minus negative 4. Be careful with these minus negatives, just like slope. All right, so this vector is negative 4, 10. You should ask yourself, which way is that pointing, right? Should be pointing to quadrant 2, something like this, right? 4 over 10 up. So it should be pointing up that way. That's perfectly fine. We just named our vector. That's all they wanted for the length. For that, they also want the length. So the length here, magnitude of V. Sometimes you'll see these magnitudes with one set of bars. I don't like doing that because I get confused about other things being that. Anyway, so here's the square root. It just says take V1, which is negative 4, and square it. And then I take 10 and square it. I'm just following this formula here at the top. All right, I get square root of 116. You could stop there if you want. This is the same thing as 2 square roots of 29. That is my distance. You don't have to go all the way to 2 square roots of 29, but the square root of 116 is a good answer. All right, we're going to push forward. I'm going to try to I'll probably just finish this lesson and we'll have it. The definitions of vector addition and scalar multiplication, given that we have 2 vectors u and v, look how they're defined there, U1, U2, V1, V2. The sum of U and V, if I'm going to add them together, gets me this. Right? I just take the x's, I take the first ones, add them together, and I take the second ones and add them together. The scalar multiple, meaning if I have some number c, you guys have seen this in derivatives and integration rules, but if I have a number c and I multiply it by a vector, c being a scalar, not a vector, when I multiply them, I just multiply the constant, whatever it may be, through both components. The negative of v, if I have a negative v, all I do is negate both of the components, so change the signs. The difference of u and v is the same thing as adding that, which gets me this same rule here. So it's component-wise, like we want it to be. Geometrically speaking, all this stuff, if we take a look at v, I'm going to zoom in here. Here's v on the far left. All right, and each one, you can see how they're affected. 1/2 v cuts the distance in half. 2v doubles the distance. Negative v shoots v the other way. So negative changes the direction of 180 degrees. Negative 3/2 v definitely shoots it the other way because it's negative. And then notice 3/2 of 1 is 1.5. Right, so that's why we went 3 spaces there. If c is positive, then cv has the same direction as v. If c is negative, then cv has the opposite direction. So just know that a negative vector is the same length, just in the opposite direction. All right, a couple of pictures here. This first one, we're going to work on geometrically how to add vectors. If I take u and v, so if we look at this first picture here, I have u and v. We can move either one we want. I think in this first picture, they move v. And what we do when we add vectors, it's a displacement thing. It's tip to tail. So I take this tip of v, and I put it on the tail of v, and I put it on the tip of u. And I put them together, and the answer, u plus v, is this displacement. It's how much it goes across. Right? So it's like if this was Tulsa, and then I think in class I said Joplin, and then Indianapolis, to get the actual distance straight across, right? If I wanted the bird's eye view, I guess would be the other word. It'd be like taking a plane to St. Louis here in the middle, and then taking a plane from there to Indianapolis. Or I could just take a plane straight from Tulsa to Indianapolis. When I add vectors, that resulting vector is our answer. So I would have some new vector that told me how to get from this point straight to that point. That's what that new vector would do. I could also, if you look, we took v and we put it up here by u. I could also go the other way. If you look at this last picture, u was moved down to v here, and we still get the same answer. Now they're in different spots, but if I explain how to get from here to here in a vector form, it would be the same as the one on the left. I just started at different points. Remember, I said this in class, so you may have not caught it. The points don't matter where they're at. It's the distances and the magnitude of the vector. Meaning I could take that dark u plus v line and move it anywhere on the coordinate plane, and it would represent u plus v. I'm going to leave this for you to look through. The resultant vector, u plus v is called the resultant vector. It's the sum of all the vectors together. We're going to see some problems where we're going to look at applications where we can put looking at forces maybe coming from different angles and ask ourselves, what is the force on that object? Meaning, like if you and I were going to push a car and I pushed from the right side, you pushed from the left side, we would both have different vectors depending on how from what angle we were pushing. All right, I'm going to work this example here. And I think this is where we're at in class. So yeah, I'm going to do this one, and then it will be the end of this video, and the next video from class will pick up here. Okay, so A is 1/2 v, vector v. So I need to make sure we can't write in boldface, so I got to put that arrow. This is 1/2 times -3, 5, the vector. This ends up being -3/2, 5/2. And leave it like that. That's a great answer. Tells me where to go. Go -3/2 to the, go 3/2 to the left, and then go up 5/2. B says the vector W. I've had a hard time writing W today. W minus V. And I just write them out. 2, 7 minus negative 3, 5. Right, so I work that out. It's just subtraction. I get 5. The negative goes to both. Don't forget that. I'm not going to write another step. 7 minus 5 is 2, so the resultant vector is 5, 2. This will, subtraction lines up here. Take a look at that one if you get the chance and stare at it for a while and ask yourself, why does it make sense that this segment is U minus V? So I'll let you think through that. The big one I'm going to expect of you, you'll have to do it in homework, is you're going to need to explain it's something along this and this. So you're going to use like a combination of those two for your homework. I have the answers up for as well, so you can see what I mean and what I want from that problem when you get to it. All right. V and W, I'm adding them together times 2 of W. I just write these out. V is negative 3, 5 plus 2W, 2, 7. I get negative 3, 5. I keep these, make sure you're writing all that in. Plus, because without it doesn't mean a vector. I get multiply here, I get 4 and 14. When I add, I get 1 and 9. So the resultant vector is 1, 9. If I were to double W and add V, what you're going to do in your homework for me is you're going to graph this. Something along those lines, adding and subtracting. It's not too bad. Just take some precision to detail. Okay, so I'm going to stop here, and we're going to pick up on Thursday right here, and maybe hopefully finish that in class.